What's up, MMS? This is Chapter 4, Lesson 2. The first thing that I wanted to talk about, actually, let me go back to the title of this lesson. This lesson is called Multiply Fractions and Whole Numbers. So in this lesson, you're going to learn two different strategies for multiplying fractions and whole numbers. And let's get started. So the first thing I want to talk about is actually something called the commutative property. So go ahead and write that down in your notes. Again, how you say that, it's commutative, and the commutative property is, it's talking about operations that can be performed in any order. So I'll give you a couple of examples of the commutative property. So one, multiplying, the commutative property of multiplying says that 3 times 4 is the same thing as 4 times 3. So it doesn't matter in what order you perform it, it's going to be the same thing. 3 times 4 is the same thing as 4 times 3. Another example of the commutative property would be the commutative property of addition. So that would look like this. 5 plus 6 is the same thing as 6 plus 5. The order is not going to matter in multiplying or adding. There is no commutative property, though, for subtraction. 5 take away 1 is not the same thing as 1 take away 5. And also with division, there is no commutative property with division. 8 divided by 2 is not the same thing as 2 divided by 8. So that was the first thing I wanted to quickly talk about today, is the commutative property. So the commutative property tells you that it's operations that can be performed in any order, and there's two examples. There's the commutative property of multiplication and the commutative property of addition. The order doesn't matter when you're multiplying or dividing. Okay, let's get to multiplying fractions and whole numbers. So the first example we're going to look at is 4 times 3 fifths. Here's our fraction, here's our whole number, and we're multiplying them together. So the first strategy that we're going to talk about is using an area model. An area model is basically a drawing of 4 times 3 fifths. So I'm going to draw 3 fifths, and I'm going to use a bar to show my fraction. So this is what I'm going to show for 3 fifths. There's the whole bar. It's divided into 5, and I would need to shade in 3 of the 5 to make 3 fifths. So I'll do that. So that is 3 fifths. This is a model right here of 3 fifths. That's this right here. And the problem says 4 times this. So what I need to do is have 4 times this drawing. So I would just do this. I'm going to repeat that same drawing. So 1, 2, 3, 4. 4 times 3 fifths after I get these shaded in. There's 3 fifths. Here's another 3 fifths. Here's another 3 fifths. So now we've got a model of 4 times 3 fifths. Here it is. Now what I'm going to do is, you have to imagine that I'm going to move, think of these as like maybe ice cube trays. It's got 5 total, but 3 ice cubes and 2 empty. So this is a tray of ice that's 3/5 full. They all are a tray of ice that's 3/5 full. I'm going to start to move the ice cubes to make full trays. So I'm going to take this ice cube right here, and I am going to move it into this spot here. So now it's gone from here. I have to imagine that it's gone, and I've moved it there. I'm going to move this ice cube. I'm going to move that one right here. So now it's gone from here, and now I've got now this is full. It is 1 whole. It's not 3/5 anymore. It's now 1 whole. I still have an ice cube right here that I'm going to move that ice cube. So I'm going to move that one over to this spot right here. So now it's gone from there. This one's now empty. And now this one is full. And I'm going to move another, so this has 1 empty spot. I'm going to take this ice cube and I'm going to move it right here. And now that one is gone. Now this one is full. So I started with 4 times 3/5, and now I moved around ice cubes. This one's now empty. This one is full. This is 1 whole. This is another whole full tray. And now this one's gone. I moved it right here. So this one is now, after I've rearranged the drawing, this is now 1 whole. This is 2 wholes. And what do I have left right here? Well, I've got 2 shaded in out of the 5. So what's left in this, it would be called 2/5. So altogether, looking at my model, 4 times 3/5, my complete answer would be 2 wholes, 2 and 2/5. So that is one strategy that you can use, is drawing out an area model. So I'm going to highlight this in an orange box right here. So that is one strategy. You're always free to use that strategy. It does take a little bit more time, and you'll need some space. You might want to get some grid paper if you like that strategy. But it's basically building what you have, 4 times 3/5, drawing that out, and then actually moving the fractions around to make as many wholes as you can, and then seeing, well, what do I have left? 2 wholes and 2/5 would be my answer for that one. All right, the next strategy is solve 4 times 3/5. So it's actually the same problem. We know what the answer is. It's 2 and 2/5. But this time I'm going to solve, and I'm going to solve by using use an equation is this strategy. Okay, so I'm going to use an equation. 4 times 3/5. Now, before I get to my equation, I have to show you that any whole number whole numbers, like the whole number 7, whole numbers can be rewritten as fractions. 7 is the same thing as 7 over 1. So whole number 7, you can rewrite it as 7 over 1. Anytime you have a whole number, you can write it as a fraction equivalent by putting that number over 1. And really what this means is, this line means divide. How many times does 1 fit into 7? The answer to that is 7. So anytime you have a whole number, doesn't matter what it is, 25 is 25 over 1. 1,067 is 1,067 over 1. You can always change any whole number into a fraction using this right here. Whole number is that number over 1. So we're going to use that idea when we solve multiplying fractions and whole numbers. This 4, I'm going to rewrite as, actually let me copy the problem, 4 times 3/5. I'm going to rewrite that as 4 over 1. So over here I'm going to rewrite it as 4 over 1 times 3 over 5. Now when I have numerator, denominator, all I do is I multiply numerators across over denominators across. That's it. So 4 times 3, my two numerators, over 1 times 5. That's how I solve multiplying fractions and whole numbers using an equation. Numerator times numerator, denominator times denominator. If you have a whole number, you're making it into a fraction by putting that number over 1. Now I'm solving this. 4 times 3 is 12. 1 times 5 is 5. I have an improper fraction, so now I'm going to change it into a mixed number. To do that, I ask this question. How many times does 5 fit into 12? Well, skip count by 5s. 5, 10. It fits in there twice. So how many 5s fit into 12? The answer is 2. And what do I have left? I've got 2 slices left, number 11 and number 12. So I've got 2 slices left, and my denominator never changes. My denominator was 5, so I have 2 slices left, and my denominator stays the same. My answer is 2 2/5. So I get the same answer. I already knew what the answer was, but not, this time I just solved it with an equation instead of an area model. So you may choose either one of these two strategies today. You may draw it out using an area model, building the model and then moving the pieces around. How many holes can you make all together, and what do you have in your picture? Or you can rewrite the whole number times a fraction as an equation, and if you have a whole number, to make that into a fraction, you put it over 1, like we showed down here. You can use either one of these two problems, and the hidden treasure today is note check, Chapter 4, Lesson 1, and Chapter 4, Lesson 2 notes. So next day when we do Lesson 3, I will draw sticks for this hidden treasure. Lesson 1, Lesson 2 from Chapter 4. Good luck. See you next time for Lesson 3.